Yes. So in this video we are going to talk a little bit about different ways of testing and how different developers usually showcase their testing maturity. So let's get into it. So what we're basically going to cover is how different devs thinks or different programmers think about testing, what the goal of unit testing actually is, and why so many, at least from what I can see, devs are bad at writing tests. So this question is basically, can you make a video where you show the differences between juniors and seniors with a focus on testing? Now, the reason why this is very tricky is because it is very hard to distinguish good testing from bad testing in many cases. And the reason why this is hard, part is hard, is because there's no consensus. There's no consensus what good testing actually is. If you go and talk to the absolute most zealot testers around, they will tell you that anything below 100% test coverage, pair programming, mob coding, there are so many practices to do testing. I mean, let's not even talk about the testing pyramid where you have unit testing, you have integration testing, and then you have end-to-end testing, and then you have like manual testing. Like, there are so many patterns to this. So if we're just going to focus on unit tests, there's usually one category of people. You have the category of people who claim that unit testing should be done in a specific way. And what I'm going to show you now is not how to write the perfect unit test. It's about trying to explain why what's good and what's bad about different ways of thinking about testing. I hope that's okay. So make that super clear. This is not a lesson in how to write good or like perfect unit tests, because I'm not going to be able to give you that, because it's impossible, because it's subjective as subjective as it can get. If you ask 3 developers what a good unit test is, they're all three are going to give you a different answer. So this is what I call a junior level mindset. Now, what I'm saying here is not that just because you watch this, that means that you already know that this is a junior developer. I want you to walk through with me the the process of thinking behind writing test logic like this. So what we have here is a user. Now that user is just an object or a class which is going to take a name. It's going to have a method called getName and setName. For the C# and Java people, this should feel very, very familiar. And then we look at the tests. So here we have 2 tests. One test that checks that if we call getName and we pass in foo to the constructor, then the name should equal foo. And then we have another test that checks that if we pass in foo and we use setName, well, then we get the name and that's going to return bar. This is beginner level logic testing. This is what you would show as an experienced developer to a complete beginner to test-driven development. Now, the reason why I can tell that this is it's not because of the simplicity of the logic. We could have done this in a different fashion. We could have used a very sophisticated service with a big server and tons of really, really cool other bells and whistles that would make this problem more complicated. But the essence of what this person is doing is to test something that is so unlikely to be a problem or cause a regression that it's basically pointless logic to test. Yes, I know some will argue that this is not the case, because technically you could have weird stuff that could break your code in getName or setName if something weird was going on. If we changed this logic underneath somehow, then yes, it could have caused a problem for us. But the logic itself is so unlikely to ever cause a regression or a bug that a normal junior might actually be thinking more about writing the test for the sake of the test, rather than think about how valuable this logic is to make sure that it actually works. I have seen many juniors who they will test every single getter and setter, if we're talking Java as an example, on every object, and put comments over the function that states something like this: gets user name. It's so trivial. It is not bad per se, but it is so obvious that this function is returning the get name that it's excessive. And if we want to abide by Uncle Bob's clean code practices, ideally what we should be able to do here is to express the intention of our code by using a method name as an example. And the testing itself is on the same level of mental of consideration when you're writing it. You're basically only guaranteeing that this is going to give you coverage because the odds of breaking it is so low. Now, let's talk about a mid-level perspective on things. Now, so it's a mid-level developer or someone who is a little bit more experienced. Now we're stepping it up just one notch, and we're talking about a little bit more of a complicated scenario. So here we have a service. Now a service is a different type of entity from a user if we're applying domain-driven design mentality. So a model such as a user, as I was saying, the internal logic of getting and setting a name, this is so trivial that it's almost borderline not worth writing a test for it because it's not going to give you anything. A service is different because in a service method, a lot of stuff can take place. So if we have a look at my services here, I have two services. I have one Sweden service and one Denmark service. And they both have the same interface. So they have an interface called take action. This method could in theory do all kinds of stuff. This is something that is worth testing. Now, not of course with my trivial little example here, but you can just pretend that this was doing something more complicated. We might have multiple pieces of logic going on, many database accesses and read and writes and all that good stuff. So this makes sense to test. Now, the mid-level developer will understand that this is important logic to test. The junior, as I was saying, they will just write the test for the sake of the test. This mid-level developer is most likely clever enough to understand that, oh, this is actually something that could go wrong, and that's why we should have a unit test, because the purpose, and this is the most important part of my entire little rant here, guys, the purpose of a unit test is not the test. It is that the logic is going to work. That's it. That's all it's there to do. It's an insurance that you create so that you won't break this at some point. If you were a flawless human being like myself, but even more than that, is superhuman, then you would be able to write code that never broke. You would be able to go into any code base at any time and just go, I already know how every single piece of logic in this entire system works, so I'm safe in changing this thing here I know that it's not going to break. And in a small system, this is possible because you have the state of the entire application in your head at all times, so it's very unlikely that you're going to break a Hello World application as an example. And if you were able to make changes that confidently, unit testing would be pointless. If humans were flawless, there would be no point in tests. So this person here has understood that this is not the case, and this logic might cause a regression. So we're going to create a test. Now, why is this not ideal? From my perspective, there is one problem with this. And that problem is basically that in this scenario, we are now we're pulling out two services, and this person has most likely thought, all right, well, these services, they have the same function name. Well, maybe I don't have to write two tests. Maybe I can save myself some boilerplate here, and I'll just create a map function that goes over these constructors here, and then I instantiate the service and then I call take action, and then I can destruct out the results because I know that these two results here are going to be these two results here are going to be Sweden and Denmark. That's it, right? And this makes it cleaner because I don't have to write two tests and I don't have to duplicate. This is very dry. I don't have to duplicate myself or anything like that. So what is the problem with this? Well, the problem is that this is a little bit too clever, I would say. It's a little bit too clever because what you've basically assumed here is that, okay, this test here, well, it's fine to just add some small logic on top of here because my use case is so simple. So what you've done is that you have actually added business logic, or you've coupled the business logic of these services to your test. You have now created a situation where if we really wanted to be anal about this, we would have to have a test for this test. because it's actually become more complicated than if you were just to literally create two separate tests for this and just keep it as simple as humanly possible. This is me now. I'm going to give you a lesson that I have found to be extremely true, and this is just a general rule of thumb, and I think that you should follow it just in general. There are exceptions, and that is that when you're dealing with unit tests, always go for the simplest, dumbest thing, because otherwise you're going to spend your time debugging why the test isn't working rather than the code. And a test is, as I was saying, it's just something you do to make sure that you didn't break stuff. It's a cost. It's an unnecessary dumb cost that we don't want. So if you want to keep that cost as low as possible, and copy pasting two tests that are basically identical is actually not a bad idea, because the times that you're going to change this is not going to it's not going to be a minor in comparison. The time you spend on refactoring this is going to be nothing in comparison to the time it could take if, let's say, for the sake of argument, that all of these things that's going on here was actually much more complicated. This is a toy example that I have created for you as a demo, but I have seen people write really advanced code in order to make their testing boilerplate a little bit less. And lo and behold, it always ends the same way. They create a situation where we now have to spend hours fixing why the test runner isn't working. And then you've defeated the purpose. Now we're basically created another problem instead of creating solutions. So let's go over to the senior spec. Now, let's have a look here. So the first and foremost thing is we're touching on what we did in the mid-level. So a senior, quote unquote, would understand that the purpose of the test is to just make sure that the take action function is working. That's it. It's not supposed to do anything else, because if you have spent more time debugging why your magical perfect dry test code is why, if you've debugged why that's working, then you've wasted time. And that's what unit testing ultimately comes down to. How much time are you spending on fixing bugs? Because the test is supposed to help you to reduce the amount of issues and time you spend on fixing issues. That's the whole purpose. So if the logic is working but the test is breaking, you have the same problem as if you didn't have a test, if that makes sense. Rather, it's actually better to not have the test if the test is actually causing you problems. So what they did here is perfectly fine. They literally copy pasted two tests and just changed a few things. And this is simple. This will never break. And the best part is that if the use case for the Sweden service changes, I can just update this. And this, I don't have to care about it. In the previous case, if any of these services start behaving in a different way, what if the Sweden service all of a sudden starts returning something else than this? Well, then I have to start, maybe then I can just add something else to the structuring. But maybe it starts adding other service calls or other logic that I need to test for. And by just magically these two things starts to diverge enough so that it doesn't make sense to have them in the same test. Now you would think that most people would understand that, oh, okay, I'll just throw this test out and just create two separate tests. But I promise you, there are almost more people that would just try to shim in the logic and the assertions into this test. They would rather just keep on appending logic and complexity to this concept rather than rewrite it from scratch. I have seen it happen so many times. Now let's talk about a batch service. So in this case, a batch service is just what I've created here. It's a very small little class here that will just pretend that this is a database instance that you're picking up, so that you give the database reference to this service, and then it instantiates, and then it's going to send out some orders. So we're going to run this in some type of cron job or something like that. And here are my fake orders. Just pretend like we're getting this from a database, and then we're going to map over these orders, and each order is going to check if the time that we pass in is past the current time, because we don't know what the current time is. A classic rookie mistake is to do this. Const current time is equal to new date. This is a rookie mistake, and it is a rookie mistake because this has now created a situation where it's almost impossible for you to test this code. Time is constant. It's move every time I invoke this function, time is going to be something different. And every test you write, you want to be deterministic, because if it's not, you're going to have to from the outside. And this, I've seen people do this. They use something like sign-on or other stuff in order to like try to reset the clock and stuff like that, in like control how time is progressing within the execution of their application. And that's just not worth it. You just pass in the time. If you pass in the time, you control what the time is. You can say that this is 100 years ago or 1,000 years into the future. It doesn't matter. It can be at any time. So just keep that with you. Now, once you have understood now that we have understood what the batch service does, let's take a look at the differences between the perspective of a junior and that perspective and the perspective of a senior developer or someone who is more experienced. So as I was saying, if a junior saw this, you might see something like this. So they create a fake database instance, they pass it into the service, and the first thing they do is they just check, is the database property there? Is it defined? And this is exactly what I'm saying. Like, we're now just writing a test for the sake of the test. It's pointless to check if the database is on a property on the service at this point, because you're never going to interact with like no reasonable person is going to reference the database like this directly, unless you are like, if you don't understand the intention behind the service. The idea is to interact with the service with the methods that are provided to you. So the test isn't really giving you anything. It's just giving you line coverage. Right. Lastly, this is what a so-called lazy senior would do. Now, there are many things that you could be testing for, but a reasonable experienced developer would understand that at the very least, you're going to have to check two cases. You're going to have to check, has the date is the date passed? Have we passed the time for when we need to send the orders? So should we send the orders? Or on the other hand, are we still not past the time that we need where we need to send the orders? Like both cases. One is the happy case and the unhappy case. That's what we usually call it. The happy case and the unhappy case. And that's usually enough. You just need to figure out what logic is likely to break. Now, had this been a much more trivial service, most seniors would not have written a test for it. That doesn't mean that they're right. It just means that they know that based on experience, and this is not always right, guys. The seniors are not always right about this, but this is how it goes. They are lazy and sometimes it's not just seniors, and they just don't care about it. But any reasonable experienced senior would say that, it's likely that I have created logic that is incorrect for reading these orders and sending them out. And what would happen if this went wrong? That's a very powerful question. This is the mark of, at least from my experience, a true senior. Whenever I ask a senior, why didn't you write a unit test for this? They usually say something along the lines of, well, I said that we were a little bit short on time, and honestly, if this broke, it wouldn't be much of an impact. I mean, it would be such a trivial thing to fix, and there's not going to be any real damage to the system. It's going to continue working. And sometimes when you ask a senior, okay, why did you write a unit test here? They will answer this thing, and this is the important part. Because if this broke, it would be catastrophic. Now think about this logic. Just try to absorb this idea. So we're sending out orders. Maybe it's really damn important that the orders are not being, because this is going to send out orders to some external system, to a customer or something like that. What would happen if this broke and we just started spamming them with every order we have in the database that isn't supposed to go out? Well, first and foremost, they're going to complain and ask, why the fuck are you sending us so many orders? And the second part is that we might have sent, or maybe if this next part of this logic would be, we're just going to send orders to certain vendors. What happens if we don't test this? Well, maybe we are sending orders from one customer to the wrong vendor. And then we're leaking data, and we're annoying our customers. So this is logic that if it breaks, it can actually cause a lot of embarrassment for the company. It can become a much bigger workload to fix it, because if it goes wrong, the time it takes to fix the problem of it going wrong is so great that the time it takes to write the test is like nothing. You would spend like maybe on a sort of complicated feature that is in this ballpark of logic, maybe you would spend a few hours just writing a really good suite of tests to make sure that nothing, like the happy case and the sad case and like all of this stuff is working. And if that, maybe that never breaks, maybe you're perfect, but if you think about how much time it would have taken for you and how much money it would have most likely cost in salaries and reimbursements and stuff like that, if it broke, it's a very small investment. So what I want you to take away from this is not that the way that I've shown you how to think, like the considerations here, this is not an absolute truth, guys. I'm just trying to relay a mindset to you. And the mindset is that a normal junior they're writing tests without thinking about the logic and the value of the test that they are writing, because they're just doing as they have been told. They're not reflecting on the impact of what they're doing and if this is valuable, if it's not valuable. They're just testing everything because they don't know any better, and that's fine, because they will grow into understanding that they're spending a lot of time on this and it's not giving them so much in return. A normal experienced developer might do something like this. They know that there are certain things that they kind of need to test, because if it goes bad, it kind of is really, really bad. But sometimes they also fall into this pit where they're a little bit too clever for their own good, and they create a situation where they're actually trying to innovate their test codes in such a way that they spend more time maintaining and fixing and making it hard to understand the test itself. So I mean, if I have a hard time on reading this test, it's just wasting time. And as I was saying, the goal isn't to create a clever test. It is about saving time. And the senior is the person who will understand that the most. This person will know, an experienced senior will usually be, unfortunately, a little bit too lazy. Sometimes they're too lazy, and that's not good. But often you will see them write the right test, the test that is going to save the company money and time, because it's testing logic that if it failed, it would be catastrophic or a lot of hassle to fix it. That is what a real experienced developer will consider when they're writing their tests. Because sometimes you can't have the position that, oh, we're just going to write tests for everything, because due to time restrictions and other stuff, you don't have that luxury. And then if you only have a limited amount of time to write your tests, then you should focus on the tests that are going to make the difference. That's what's so important. Have a great day.